Hi, in this video I am going to talk about row measure and column measure representation or mapping. Here we will learn how compilers manage arrays, either single dimension or two dimensional or three dimension. How they manage the array means what the machine code they write when we use arrays in our program. So let us see. Here I have declared an array of size 5. In our program, when we declare any array, then at runtime we get the array space of specified size. Here the indices are starting from 0 to 4. As a C language example, if we take, this is called as base address, or this is also called as location 0 or L0. So L0 here is 100. In our program, if we write a of 2 assign 15, here is 15. When we write this statement, compiler will convert this into machine code. So for storing the value 15 at this particular location, it needs the address of that location, and that address of that location is 104 as per our example. So here it should be replaced with 104. So let us see how compiler will make it as 104. So when we use any index or any location of an array, when we access, compiler will convert it into a formula which will get the address of that location at runtime. So let us see how it will write on the formula. Address of a of 2. This address cannot be absolute. It will generate a formula for getting relative address. So for relative address, the base address is taken, L0 plus the index what we have written, 2, then into the size of the data type. Here we have taken integer as a data type. So integer is 2 bytes. So that is 2. So this is size of data type. So at runtime, if the program is getting the memory at location 100, that 100 is becoming the base address of an array, then here it will be 100 plus 2 into 2, that is 104. That's how it gets the address of any location. For any location a of I, to get the address of any location, compiler will replace it with the formula L0 I into W, and W is word size. This is index and this is word size. So word size is the size of data type. If it is float in C language, it will be 4 bytes. If it is character, then it will be 1 byte. Depending on the data type, the value of W may change. So this is how the formula is written by the compiler. We write simply a of I or a of 2, anything, but it will be replaced by the formula by using that particular index. Some languages prior to C language, before C language, languages used to allow the indices starting from 1 onwards. So here you can see the index is starting from 1 onwards, and in the declaration also array A starts from 1 ends at 5. Now in this case, what will be the formula? So for getting the address of any location, a of I, formula will be L0 plus I minus 1 into W. As per this example, if we get the address of a of 2, then L0 is 100 plus I is 2 minus 1 into 2. So this gives 100 plus 2, that is 102. So yes, this is 102. Index of 2 is 102. So this is the formula used for accessing any location if the indices are starting from 1 onwards. This used to happen in the languages before C language. After C language, every language started supporting arrays indices starting from 0 onwards. The reason is, if you see the formula for indices starting from 0, just now we saw the formula was L0 plus I into W. If you compare with this formula for indices starting from 1, then one operation is extra here. Minus is extra. So from C language onwards, this extra operation is removed and they force the programmer to declare an array starting from index 0 only. Now before that C language, some languages used to allow the indices starting from any index, ending at any index. Let us say even we can declare an array A of -3 to 5 as some type, let us say integer. So even this was allowed. So if the language is allowing the indices like this, it depends on the compiler. If the compiler is allowing it like this, then what will be the formula? So the address of any location A of I can be obtained by taking L0 plus I minus lower bound into word size. This will be the formula for any starting index. That's all for one-dimensional arrays. Now let us go to two-dimensional arrays. In two-dimensional array, there are two options. Either a compiler can follow row major method or column major method. So there are two types of mapping. Here I have declared an array of size 3 by 4. And we draw using pen and paper, we draw an array like this with indices so and so. But in real, the array will be created as a single dimension in real, because memory is linear and the memory has a single value address, that is integer address. So actual array will be created like this, but compiler will allow us to access the array in the two-dimensional form. So I have taken the addresses 500, 502, 4, 6, and the next is this is 8. This is this location. So this is how the addresses are taken. Now first we will see row major mapping for this one. Here I have taken some elements. I have also filled with the elements. Then let us see how these elements are stored in real in the main memory. A00 is stored here. Then A01, 02 and 03. This is first row. The next 10, 11, 12, 13. This is second row. So the elements will be filled row by row in row major mapping. So compiler maps this two-dimensional array on this single dimension array. So the elements will look like this. Now this is row major representation. The elements from this 2D array are mapped on a single dimension array, row by row. This is row 0, row 1, and this is row 2. Now let us see how the compiler will make use of base address and generate the formula. For getting the address of an allocation A of 2, 1. Now 2, 1, if you see, it is 518. Here it is 518. So this will be location 0 plus location 0 is this address. Now it has to go to second row, so you should skip two rows, first row and second row. So it has to skip two rows. And in each row, how many elements are there? The dimension of this array is 3 by 4, 3 cross 4. So each row is having 4 elements. So this is 4. Now when you skip two rows, you will be at the beginning of third row. That is row 2. Now you have to move one element ahead. So that is 1. And this whole thing is multiplied by the size of integer. So this gives 500 plus 9 into 2. So that is 518. So this is how it gets the address. So it means for getting the address of any location a of I comma j, compiler will write the formula L naught I into, if the dimensions are m cross n, then this is n plus j, and this is word size. That's it. This is the row measure formula when the indices are starting from 0 onwards. If the indices are starting from 1 onwards, then the formula for any location, address of any location, is written as L naught plus I minus 1 into n plus j minus 1. This whole thing multiplied by w. Let us find the address of 3 comma 2 here, 518. So address of 3 2, L naught is 500 plus 3 minus 1 into 4 plus 2 minus 1. This whole thing is multiplied by w. And this is 500 plus 8 plus 1, 9 into 2. So this is 518. That's it. This is all about row measure representation. Next we will see column measure mapping or column measure representation. I have taken a two-dimensional array, and basically the array created in main memory will be single dimension, and these will be the addresses. Assume that address starts from 500 onwards, and I have taken some elements. Then how the elements are filled are A00, A10, A20. This is column 0. Then column 1, column 2, and so on. So the array looks like this. Array looks like this. Now let us see how the column measure formula is written. If you want to get the address of a location, that is a of 1 comma 2, 1 comma 2 is at 514. So address of a of 1 comma 2 is taken as location 0 plus. Now 2, it has to go into second column. So location 0 is 500, it's here. So it has to skip two columns. So two columns. So as the dimensions are 3 cross 4, that is m cross n, number of elements in each column are 3. So this is 3 plus. Once we skip two columns, we will be here in the beginning of third column. Then we have to move only one location, that is what I. So this is 1, and this whole thing multiplied by 2. So this is 500 plus 7 into 2, this is 514. If you make it as a formula for finding the address of any location I and j is L naught plus j into m plus I multiplied by w. That's it. This is the formula for column measure mapping. In some languages, array indices start from 1 onwards. Then what will be the formula? Address of any location A of I j will be L naught plus j minus 1 into m plus I minus 1, whole thing multiplied by w. If we want to get the address of any location, let us say A 1 comma 4, that is 518. Let us get the address by putting the values in the formula. Address of 1 4. This is location L naught is 500 plus j value is 4, so 4 minus 1 into, this is 3 cross 4, that is m cross n, so m value is 3, so 3 plus 1 minus 1. This is integer type. If you assume that this is integer type, then this is 2. So this is 500 plus 9 into 2, and this is 518. That's it, we got the address 518. Now finally, let us look at the formula for row measure and column measure mapping if the array indices are starting from 0 onwards. Both the formulas are given here. L naught plus I into n plus j into w, and here j into m plus I into w. If you see the operations, this is having 1, 2 addition operations and 2 multiplications. So here also 2 additions and 2 multiplications. So we can say that both the formulas are equally efficient. Both are equally efficient. So a compiler can use any one of the formula. So if we are designing our own compiler, we're developing our own language, then we can use any one of these formulas. But the C language and all other languages that belongs to C family, they use row measure mapping. That's all. Thank you for watching the video. Please leave comments so that I can improve the videos based on your feedback. Thank you for watching.